Check, check, check. Okay, computer did an update, so hopefully everything's the same. We'll see. Alright, let's get to work. So I'm just going to spend a bit of time sorting this out here. So what we do is we do a tick async sprite position. I think what we need is we actually need the level submesh. So tick async needs a bunch of things. It needs the position and the level submesh. Submesh. Like that. I'm just going to leave it like this for now. This is probably not going to be how it actually ends up happening for reals. I'm just not happy with doing we have to, where is it? Where we have to like do this step here where we build up this vertex offset array. We shouldn't need to do that. So now that we have the level submesh, we can do things with it. Let's have a look. Got this thing called leaf transition deltas. Translation deltas. So we're going to rename this to just translation deltas. And get translation deltas here. And this is, where are we? So this is 1 per leaf in this situation. In this situation, it needs to be once per vertex. So this is going to be submesh. Submesh.indexRange.count. Like that. What's this? Doesn't know about level submesh. That's in game level. Alright, so what we want to do is we want to go with each So we'll go 4. Oh, this doesn't have actually the trunk indices in it. Okay. So we actually need the tree as well. The level tree. Maybe this could happen on the tree then. That's a bit better. Alright, I'll take that back. Rather than on the tree simulation. Alright, start again. So level tree actually does this. So this is void tick async. Vec2 offset const submesh index level submesh even submesh and canvas. So that happens on here. Yeah, this is a better place for it actually. So let's copy this whole thing over to there. And this now is auto leave states equals simulation get leaves leaf transition deltas now. This just needs to be an array. Array vec2 translation deltas. So this is submesh index range.count. Morning, Fu Manchu. How's it going? Hope you're all right. Night child, morning. Good morning. How lazy and how Ben are you? 100% Ben. I'm not lazy, no, to be fair. So 10 Ben and maybe 2 or 3 lazy. Hope you're doing all right. I'm just going through. We got the trees in yesterday, but I'm just changing it around a little bit so the API is a little bit nicer. Ben 10, yeah, that's right. Okay. So what we need is, so we're filling them with zeros, with a bunch of zeros. Which is probably fine. I mean, we could do it quicker than that. Saw the animated trees yesterday. Oh, yeah, cool. That was the pun. Yeah. It was more of a... I just had loads of trees in the level. Just to check, obviously, that the level compiler worked with trees. And because it's a particle simulation, they're quite intensive on the CPU, really. So I think eventually I'll get them moved over to the GPU. It's probably fine. The beginning of the end, yeah. But yeah, it'll be fine for now. And then when I do, so once I've done the actual content pipeline compilation stuff, I'll move on to actually pass over how the actual game renders the level. And we'll look at putting it on the GPU then, probably. But right now it's on the CPU. It's on the CPU and it just runs asynchronously. And it had all them trees running at less than a millisecond. Which is, you know, that was 38 trees. Each tree's got about 3,000 particles on it. On the CPU. So it isn't too bad. And that was only over 8 threads, actually. But you'd want it to be like that, wouldn't you? So GPU might be better. Why on the CPU? Just because I haven't written on this. It was always on the CPU when I originally wrote it. Just haven't got to the GPU yet. The tree particle simulation stuff is years and years old, that code. We're talking maybe 10 years old. I first wrote that system. So it's just got ported into this engine and then left. But we'll do a pass on it later. Need to upgrade the code from 1999. I don't think I have any code from 1999. Definitely code from like 2014, 2015 though. In here somewhere. Including that tree stuff. So this fill with is a loop. It doesn't really need to be. We have a fill clear. The problem with that is it doesn't work. I don't think. Because Vec2 has a constructor in it. Alright. This is offset. Right. this is translation deltas. Yeah, so fill clear doesn't work because it has a constructor. Here's the thing, it could work. I wonder if I should just knock off that. Fill clear is a lot faster than just going through and putting zeros everywhere. Okay. So this, we need an actual offset for J for this to work. So we're going to have the offset for J is the simulation. No, is the trunk indices count, maybe. And that's there like that. So the idea is we have these translation deltas, but because the tree is just one mesh, trunk and leaves, when I apply the deltas, I just want one delta per vertex. This isn't actually per vertex either, so we need to change that. This is per leaf. And leaves can have any number of vertices. Oh, we're in that. Okay, we need 2 game levels open, so I can just copy this code over. Okay, so that isn't the offset. No, that is the proper offset. That is right. This is different though. We need to go. So this is per leaf. Leaf state count. So we want to go auto. What's just this? Or tree. Leaf indices J. That's not quite right though. This isn't right. I think I'm going to have to just run this code to check. So if we do that, we don't have to run it asynchronously. So this is take async on the tree instead of the simulation. So we'll do it here. Free.tick async sprite.position. Submeshes sprite.submesh index canvas. Not sure about this. It might be this. It might be that. I'm not sure. Something like that. Find out. We shall find out. Okay. Per vertex. Per vertex, yeah. So there's per leaf. So before it does it per leaf, and then what it has to do is take every translation per leaf and apply it to every vertex. What I actually want to do is just build up a list of vertex translations rather than leaf translations, and then have the extra step of applying it to the vertices. So we're going from 0 to 75 of leaf states. J offset is 96, so that's where we're starting off in the vertex buffer. It's called J for some reason, but we'll get there. So yeah, so that gives us the leaf state. It's withheld per vertex because you've put per vert x. That's funny. That's funny. Yeah, that's funny. Very sensitive, this chat thing. Right, so that gives us the leaf. So we're in the leaf now, so we need to basically simulate the leaf. And then we have our translation delta for the leaf. And then for this leaf, we have a bunch of indices. Oh, so we don't need the offset, it's already there, look. We don't need J offset. This might actually be okay. So for every leaf index, so there's 10,000 vertices in this tree, and each one needs a translation delta. So that should do it actually. So let's just step out of here and check that we don't crash. We didn't crash. So if we put that back to being asynchronous now, it can do all that in parallel, you see, and then we can flush, and then we don't need this step anymore, this vertex offset step. This can just be tree translation deltas like that. So let's see if this runs without crashing. Cool. I got rid of the level with all the trees. There's only 2 trees. So even though there are more vertices, there are 10,000 vertices, 9,000 translation deltas. I'm not sure if that is a problem. So that starts at 16, that starts at 0. That seems wrong to me. $9,844. So what's count? We need to actually put in some NatVis for count for this. 9. It's like 9828. 9828. 9828. Should we put NatVis in for that? Index range. LibBM. No. Is it in LibBM? It is. Index range. Okay. We'll put some NatVis in for that, because why not, eh? Type name BM index range how do I want this to look? Display string condition last minus first equal to 0 empty. How does it work? How does this normally work? I think we need to do this. So where are we? Here. Well, that didn't work. That didn't work. Why didn't that work? Index range base. Right. So it's not quite that. It's index range base that. Count. There we go. 9828. And we've got 9828. So that's awesome. That's gonna work. That's fine. They line up. That's much better for an index range, that. Bamberg, how's it going? Good morning. And Borochecker, how's it going? Ahoy. Hope you're alright. Cool. So, if we go to game level again now, that's much nicer. So, I'm going to take out this tick async for simulation, so we don't use that now. Get the right one. Tree simulation, tick async. Slept 11 hours, brill. Tree Master 25, yeah. Tree Master 2000. Slept 11 hours, that's great. Okay, that can disappear now. Maybe today is different, yeah. If you got good sleep, maybe today is different. Anyway, that would be the new way to draw all the trees. We do have to iterate over them twice, but that's because, you know, we're doing this async thing with the simulation itself. We have to do like a tick and then a draw and flush in between. Eventually, it would just be a draw and the tick would get done on the GPU eventually. Renew my memberships. Alright, okay. Yeah. Oh. So now I'm going to consider that kind of like draw a line under that now. We might like so the thing about this is that's how the game does it. The actual editor does it all in series, so like the editor will slow down pretty fast. Probably if I just start adding loads and loads of trees in. Well, we're on at 10 frames. So does this affect the stream? It shouldn't do because it's just a single thread. Move to GPU. Yeah, exactly. Can I go to the gym because the card expired? Really? Interesting. Usually they just want you to go, don't they? Keep, I suppose, if they can't get payment. Sounds not very economic to have two systems for the same. The thing about it is it's not actually two systems. That's the thing. One the way it works in the game is like the data is entirely different. You know, the data's been it's been like crunched down into like one mesh and one texture and stuff. Whereas in the editor, it's like thousands of textures a tree, unfortunately. But yeah, like if so to make it work like that in the editor will need like a pre-pass step as well to crunch down the actual raw PSD file into something like more optimized, which we don't have yet. There is space for it because if you go to the asset editor types, we have content brush generator. So this generates the brush, so the tree brush that you stamp into the level from the PSD file. But the idea is that it's not meant to have any assets in it. So like I'm not going to copy out the PSD file textures into the content brush. Or maybe it does do that. I can't remember, particularly for a tree. Let's have a look. Well, it does copy them out. It copies them out of the PSD file and then makes a new DDSA file, which is basically like all of the layers in one file, all the PSD layers in one file as DDS images. But they're all separate images. So, you know, when the editors go into the GPU, they're all going to have to be, they're all separately put on the GPU. But, you know, we could do some kind of, it would be here anyway when we generate the brush for a tree. We'd have to do some kind of wizardry, you know. But this is like a super duper stress test. I can't see a situation where I'll have like 50 trees on screen at once. But maybe. There we go. So that's 12 frames a second there. It's not using much. Well, here's the thing, like it is only using 3.5% of the CPU there, but that's because it's not doing enough work. So we could, in theory, where is it? I've just got this set to like hardware concurrency. Then there's another slow bit as well, which is where it builds the mesh. So we've got these building the translation deltas, then it has to build the mesh after that. Enough for everything. One core full used. Yeah. So I could put this down to like 8 or something. But I'm not sure. Like that's gonna have to get we'll look at that if it becomes a problem. You know what I mean? It would be much faster to do it on the GPU. See, it's only taking 1.8 milliseconds to do this. That simulation. The rest of the slowdown is probably in building the mesh out. for all the trees to be sent down, for that simulation to be sent to the GPU, you know, for that all the vertices to be sent to the GPU. So that's like 6 milliseconds if I'm using all of the threads. But if I just put it down to like 4 threads. .8, 1.9. Roster, how's it going? Shouldn't it be the other way around? Not necessarily. You need to pump a lot of data through these cores to make them work fast in this situation. You need, you know, like cores like a shopping bag, I suppose. It can hold all this shopping. But if you're only putting a few grains of sand in it, there's no point. You need to load them up with work. Nice one. Otherwise, it spends all its time just like bringing in data in and out all the time. Actually swapping context and stuff. So this would run if I spent time multi-threading the mesh building stage. It would run at 60 because the mesh building stage will take a similar amount of time. But I'm not going to do that yet because that's not kind of what we're working on. So there's a lot of overhead if you cannot split 1 millisecond of work across cores. You're just not giving enough core enough work, basically. That's all it is. If there was more, if there was more leaves to simulate, the performance would stabilize out across all cores. It's not me that's like, it's the synchronization of the operating system basically that is slowing that down. Synchronizing all the work. Unless that is hardware concurrency is not doing what I'm thinking it's doing. Oh, I've taken the thing off. Oops. The timer off. does get job batch do? So you have how many things you want to work on in total, how many cores you have, and then it gives you a batch to do. So say you've got 1,000 things you want to work on and you've got 10 cores, it'll give you 10 batches of 100 things to work on. I'll show you. So there's 2,419 leaf states, 32 cores. So when I do that, we'll get a batch, and it say you need to work on leaf state 0 to 75. And then the next time it comes around, it's 75 to 150. So this batch gets passed into a thread, and then it's going to work on. So each thread works on separate parts of the array, essentially. Oh, ads, sorry. So let me just. So so it's like, how many things have we got to work on? 2,419. How many threads do we want to work them on? And then it gives you a batch. So this is like, you're going to work, this batch is going to work on 0 to 75 of these. So when you pass that into the job, it just works, goes through the batch. And then the next time it's 75 to 150. So you end up spinning up all these threads with jobs across each thread, like workload across each thread, which I call a batch. Is there some synchronization in that run job block? So what it does is it just adds a job to the job queue, interlocks the how many jobs are in the interlock increments, how many jobs are in the queue, and then it resumes the semaphore there. So it'll wake up a thread. So a thread will be sleeping essentially, and it'll wake one up, and then that will look in the queue and pull something out. But there's no locks essentially. There's no locks really. Where are we? So this is it. This is each thread here. Thread proc local. So it does a wait on the semaphore. And then when the semaphore wakes up, it does a join, which does this, which is an interlock compare exchange to get the job out of the queue, and then just runs it. The job queue system as well is like 10 years old, so there's not really synchronization now. There's just not enough work in the thread worth waking it up. So it spends all its time in Windows being woken up or shutting down. It should scale better. So it's not the amount of threads you use. It's not just that. It's the amount of work each thread has to do. It needs to be balanced. You can't just throw more threads at it, because the operating system is not just my 32 threads. The operation's got thousands of threads that it's working on. That's trying to synchronize that, all those together onto the cores of the GPU, of the CPU, for all the other processes that are happening as well. So you need to just put a decent amount of work in there, so it's worth waking it up. So it's not worth waking it up. It's not worth waking up 32 threads for this work. But if I split it and I just wake up 8, which means these batches are going to be bigger. So now the batch works on 300 at once. Then it's more work for each thread to do. Less time that the GPU, Windows has to synchronize, and then you get much more performance out of it. 16. So what it is, there'll be a sweet spot between the amount of threads and the amount of work, and really good engines monitor that all the time. And they try so this wouldn't be hard coded. This would be like a number that goes up and down, depending on how much work was probably done last frame. It'd probably do it. It'd probably keep like a rolling average. So yeah, for 16, about 3 milliseconds. If I do 2. So that's split over 2. And if I do 1, that's not too bad. What will 1 do then? 1 might give it 2 jobs still, maybe. Oh, actually, no, hang on. This is happening per tree as well. That's what's going on there. So that's 32 cores per tree. And there's also loads of trees. That's what's happening there. So that's running 1 tree per thread there. So maybe that would be better to do it like that. Yeah, that's what I was getting confused. So there's lots of trees, yeah. So it was actually spinning up, when you're doing 32, it was actually spinning up 32 times 92 jobs there, which is too many jobs really. Yeah, 32 times 92 jobs. So now it's going to spin up 92 jobs. Yeah, that's what's going on there. So if I do that, it's 1 job per tree and flush them all. Yeah, that's good. Thanks for got me to notice that then. That was good. So it was already having enough jobs. So 1 job probably enough. It depends. The thing is, it depends how many trees there are as well. You know what I mean? If there's only 2 trees, that's just 2 threads. If I did it like that. So the inner loop should likely not be jobified. It depends how many leaves on each tree. Depends how, you'd have to basically, what you would have to do, I think, to get this to work well is look at the actual level and optimize for that level, depending on how many threads. So you could try and general case it. But I think to get it to work really well, you'd be like, well, this is the forest level, so we'll do this render path for the forest level instead, and that could be tuned. Because this is like, doing this here there is no inner loop here. There is no inner loop. This just goes straight through. this is equivalent to not being there. So I could just literally do that. And then pass in the actual index range. So this is doing it on the outer loop. This is doing like 1 per tree. But, you know, you might want to do like 3 trees per thread or something. You know, you'd have to find the right balance. So that's like about 2 milliseconds simulating all that. So if we were to break it up, so if we were to put the job batch like outside, so we could do like 3 trees per thread or something, you might get a bit more performance gain out of that maybe. You got a load of trees. Could try it if you want. Which means writing it. This is all. This you could do 3 trees per thread and it would be thread safe. That would be fine. So you could have a job batch here if you wanted to. If you had loads and loads of trees, that might be the better way to do it. So if we put like 2 for now. The thing is more. There's more likely going to be not many trees. So that's 2 jobs per tree. That. Modern job systems would rather create all jobs and then schedule them once. Pushing one by one to the job system is needless overhead. So create all the jobs and push them all on. Yeah, I mean, you could imagine doing that. I don't really know. There's no real overhead pushing on a job though. So all it is an interlock increment. That's all it is. So you could imagine like if you wanted to push on all the jobs and then you would do like you would increment by as many jobs that went on the queue. Do you have issues with GUI-based engines and prefer the code-based framework? But I think what it is with me is that I just write the GUI that I need. I think that's basically it, just to cut down the amount of work. Waking up a worker thread. Yeah. So what you're meaning is, say 16 jobs on one thread. Is that what you're meaning? So you'd do like 32 threads. Each thread has 16 jobs on it. So this job system supports that as well. You just have to structure the job the right way. I know I'm good. Debug stuff is fine. But I mean, the engine's a full GUI app. I don't think it's gonna go. So you're definitely gonna have to be able to code to use this engine. I would say it would take too long, I think, for me to build out absolutely everything with GUI. The tech demo type of games. Ah, right, yeah, cool. Yeah, the game tech. Game tech is what I like as well. It's very different building an engine to building a game. They're completely different fields, really. But yeah, like Nightchild, if you wanted to do like 16 jobs on one thread, you would just create the job you create would do that. It would do this. It would do all that workload that you wanted to do in one thread, and then you would only have to wake up one thread with the schedule and everything. Yeah. Every sane engineer likes tech coding. Yeah, what I mean is games tech. So like, one of the common comments I have is like, why are you building your own engine? But that question's very framed around, you're a game dev, right? You make games. And what I'm saying is that, no, games technology and games are actually two different things. You like making games, you like making games technology. They don't have to overlap at all. And I fall more on the games technology side than the games side. But I am going to try and make a game as well. That'll be good because I've got not much experience in it. Do you get overwhelmed by the GUI engines? Oh yeah, there's a lot to it. It's like writing a multi-purpose game engine, make any type of game for any type of skill level. The person actually using the engine is a lot of work. And because I can already code, I can actually build this engine out for someone who can code. I tried making games and the two got. Yeah. Made by you or it's invalid. Yeah. Maybe you're more of a games tech guy then, or just a tech guy in general. Yeah, it's very different. So there's another side to it, where if you're trying to make a game, you need to obviously maximize the chance of you being able to finish the game. And some people, take for instance, Jonathan Blow, he makes all his own engines and stuff. He makes his own language, for instance. Some people just would find it mind-numbing to use something like Unity because he likes to be stimulated by the tech. And if he decided to make a game in Unity, he'd never finish it because he'd just be so bored probably, or frustrated. So it's a requirement of people like that to make their own engines to finish games. And if you're trying to maximize it might take him longer, but at least he gets it finished, Yeah, cool. Games are difficult. Making games is difficult. I think it's more difficult to make a game than to make the tech. Personally, I think that. Linear path, yeah. Yeah. I think one of the reasons why it's really hard to make games is you have to write. So you start off with a blank text document and you've got to write something that's fun. That's difficult, especially when for almost all of its life, it's not fun. The thing that you're making, but you need to know that you're on the right path to something that's fun. That's very hard. Yeah. Yeah. Awesome. We'll leave that at 2. I don't really know what... Like I say, this is probably not going to happen. This is probably actually... He's just going to go in the GPU eventually. Yeah. I think one of the difficult things about games as well is that, say you introduce a new stat, like luck, to the game. It's not just a number. You just don't want a number that goes up and down. Like, that number has to have a whole host of gameplay systems built for it, which gives that number meaning in the game. So it's not just a number, like, and every number that you introduce needs gameplay systems that support it. And those gameplay systems have to be fun. So it's not like, yeah, let's just give this guy luck. It's like, right, let's give this guy a look and design a bunch of gameplay which makes it rewarding for the player to, you know, pursue the luck path in the game. You know, that is hard. The game doesn't always have to be fun. Yeah, I mean, it's also like fun is different for different people, isn't it? Like, take Elden Ring, for example. That's a good example of that. It's a real, you know, those games take a chance because lots of people don't find them fun at all. Yeah, still player first games, yeah. Yeah. Or it's not a game, like if you just introduced luck and it was just a number that went up every half an hour. That's not a game either. But it had no other meaning. Yeah, the actual game dev journey that I will be on will be an interesting one for me. Try and get something that is actually fun to play. Idle games are not games. Okay, cool. I'm going to delete all the trees out of those at that level now, and we're just going to... Actually, just... Well, yeah. We want to work on lights. I think it's lights. I think it's lights next. Let's just have a quick look. Let's take this out for now. So we've done that, 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 we've done that. So that's everything kind of sprite based. So we're going to do lights, I think, next, because all of these can, in theory, be lit. Okay. Yeah, I think one of the things is, I suppose, when you start out with a game, you need a kind of a clear idea of the type of game you're going to make. Because then, if it will appeal to that type of person. So if you're going to make like a type of game that is meant to be played 5-minute intervals on the train, you need to know that from the beginning, I think. So let's get this one. So it's there, but it's not lit, you see. So we need to work on that. I need to get it lit in the game. So that is basically a normal sprite for normal content data. But it has lighting in it, look. So this here, this content brush instance is an editor thing. And it has lighting built into it, which doesn't get passed through into the game. So how do I want to do this? First of all, what do I actually need? So this IMF32 file is the light data. Well, it's the distance field for the light, and then these are all the properties of the light. Sprite sheet light properties. So I have level light properties as well, which I think is the same. Just with no constructor. Oh. I assume that is... We have a level light. Interesting. See how lights are actually rendered. I'm just trying to familiarize myself with how it actually works, because I can't remember. Now I have to somehow get Pix to capture the right window here. Which it never does. If there's two windows open, it always captures the one that I don't want. There it is. It never captures the actual foremost window, it just picks a window at random. Enable experimental features. Oh, it doesn't work. D3D12 enable experimental features. Do I even... While these ads are running, I'm going to go make a cup of coffee. Back in 2 minutes. New coffee. Do I do D3, D12? Airport experimental features. I don't. That's not me. I'm not sure what's going on there. Okay. Well, I think the way it works is it just renders the actual sprite and then it renders the light over the top of it in 2 passes. First pass directly on top of the sprite. Second pass in front of basically everything because it's meant to be like a bloom on the camera, I think. First things first, we need to actually... So we'll work on this level light thing. Do we want to make it a sprite? We maybe do. A separate sprite that's like a light sprite. And then that means the level light is just a sprite index. And that has a submesh index which will have the actual texture index in it. We've got like position and Z position as well. Let's go with that. So we're going to go U64 sprite index. And then these, I think. Got a glow Z bias. Z position. Don't know what Z position is. It's not used. It's not used. Okay. So we'll go for this type of thing, I think. This is part of the old system, so I'm just going to F0 this out now. Alright, so the level data generator in append sprite, we should basically, if it's got lighting, so is anyone actually needing the sprite index? Let's see if we can get away with not having this happen. well. Yeah, let's get changes to void. It's fine. Rename it to append sprites now. Because this is also going to go through a path that appends the light sprite. So it'll be if instance.lighting and that's whether it's got any layers or not. So we can just do that essentially. Doesn't know how to. It doesn't know how to put that into CPP file. Can't even do that. How would you put that into a CPP file? Seems to be okay. So if there is lighting, put some lighting in somehow. We want a new sprite. So level sprite, light sprite. Maybe it's one for each layer. So where is it lit from? That's what I want to know. If it were a sprite, where do we get the position? Light file, from the light file. Okay. Vanberg, how's it going? Welcome. All right. CC get light file. Instance lighting. So where is the light file? In the layer. So it's actually multiple sprites. Right. So for auto light layer in instance.lighting.layers. So actually we don't need that bool then if it's going to be one sprite per layer. I'm trying to see if we can upgrade the graph visualization. Cool. Label plus the assembly. Yeah, nice one, nice one. So this is light layer. Light file path. If not light file, continue. So now we have a light file, and the light file has stuff in it. So the override properties must be one per light file. High level instructions. Ah, cool. Cool. Sounds fun. Sounds good. Okay, so the light sprite. So dot ID is the layer, is the light file, is the layer ID. Dot type is, we're going to say, we'll make a new one called light. Dot position instance now is light layer light file local offset, I think it was called, plus offset. Light layer. Yeah, that's awesome. Awesome, Van Bjerg. Now you've had 11 hours sleep. Hopefully you bosh it out. That'll be awesome. The wind is so strong. There's a storm outside. It's blowing the door open. One sec. Oh wait, don't want to slam the door. All right, origin. So let's go back to the light file, wherever that is. The origin, I don't think is anything. Z bias is equal to brush lighting. We've got glow Z bias, but that's not the right one. I think this is just instant Z bias plus Z bias. Like that. Bit weird because it's high level and low level. Oh, really? Interesting. Okay. So shadow bias doesn't cast a shadow because it's a light. Reflection bias. Not sure about that either. Room ID is the room ID. But submesh index is equal to the submeshes add unique instance brush. No, submesh index is the light layer. ID. Okay. All right, yeah. Some that are not fused. Yeah, nice. So we're going to do the light sprite index. Sprites add light sprite. And brush lighting then is an array of sprites. That's what that means. Rather than a sprite index, it's an array of sprites. So is that what we want? It has to be. No. Oh no. It was one level light. One level light. So level light. Light. I'm gonna call this actually new light sprite. I'm gonna call this new light. So got sprite index is the light sprite index. Glow world bounds is the light layer or the light file, one of these. So the glow world bound, what is that? Glow world bounds. We don't know what that is. Assuming we need that for culling. So the light file has some bounds in it, doesn't it? It has local bounds. So we'll do local bounds for now. Shadow world bounds. That's basically like anything in this bounds is going to cast a shadow. We'll do local bounds for now. I'm not really sure how we set that. Width, height, world. Width, height. The distance field. It's from the distance field. It's worth maybe actually keeping this up here. That means we need to load the distance field in. So let's load the distance field. So auto distance field is cc get say texture light file. It has no idea about so where's the distance field stored? The light layer. There's no idea about the IntelliSense for that. All that. Light layer. Distance field path. So if there's no distance field, we have to continue as well. We can't have a light. So the width height is vec2u distance field width distance field height. And the width height world equals bmcast vec2 width height divided by pixels per world unit. So auto light P is that. So that's light P. So now we can do these. So that is rect light P with height world. Not quite. We have to actually. So that's the position. That's probably the center of the light. That light P. So it's actually inflate from the center with height world over 2. Is that real code? Yeah. So I'll inflate it like this. And that is just basically 2 times. So it can cast 2 shadows. So we have the distance field. And then the shadow capture region, the cast region, is just 2 times the size of it, like that. Or 4 times the size of it, 4 times the area. Okay. And then glow Z bias. Glow Z bias we don't seem to set. Oh, here we go. Glow Z bias. Light.glow Z bias. So there is. So it's glow Z bias next. It's just the light. Instance lighting. Where's the glow Z bias? It's on the layer. It's on the layer. Light layer. Glow Z bias. And then the properties. So dot properties is level light properties. It's a shame that the formatting doesn't work for that. So that's layer, light layer. So what is it? RGB 0 equals light layer properties. So RGB 0. Light layer. It's override properties. So it's override properties we want. I think we're just going to do this separately. So we'll just copy this. So this is the new light. So props. So this is actually R index ref P or L light layer in instance dot lighting layers. Oh, so it's just on the layer, the override properties. So, my mistake. So what's the memory limit? It keeps doing this. It's got so much memory, and the computer's got 32 gigs of memory. There's open properties. And I can't find anything about memory. Oh well. So this is lighting light layer dot override properties. Override properties. Value or just sprite sheet light properties, I think. Is that right? Or is it the, where is the default properties? Ah, it's in the light file. Light file properties. Okay, so that's the properties. This is just props dot. All right, cool. And then we can just add this new light in. So the context level dot get lights, which there isn't. So we have in here an array of level lights, I assume. Yeah. So let's just do array level light. Get lights. Should be lights. Dot add standard move new light. All right. So that adds in theory, a light into the level, or some of it, the properties anyway. We need to add in the distance field as well. Ooh, need to actually compile the level up to run that code path there. So we've got one lighting layer in there. So we add the light into lights. So level light, got one light in it. These things get chucked because we just reference it to sprite now. That's properties. Right, okay, cool. So if there's lighting, it will add one sprite per light layer. So what we might want to do as well is, so we've got the light sprite index, but we actually want to tie it to the actual base object as well. So it's going to just be on a sprite index. So dot owner sprite index is equal to the sprite index, wherever that is. That way, like, if we ever like stop like rendering the owner sprite, it won't render any lights as well. Okay, so what we need to do is, for every level sprite, for every level light now, oh, we need to add in the distance field texture for that light. How do we want to do this? So we need to be able to get back to the distance field, so the light layer. So the brush has lighting on it as well. So that's how we do it. So we only need the distance field. The distance field should be the same. We're getting the lighting off the instance because we've got this override properties, so you can override every single instance with, you know, different light color or whatever. But the brush itself, okay, so what we need to do on the texture generator for normal add image, or append tile set. We need to do brush tile, be different tile book though. Generate textures here. So we're doing a tile book for every brush. Call append tile set. I want to know is how doing stuff with formats. How does this work with formats? That needs to go in a different tile book. Need a brush tile. Okay. So we need to add a new brush tile in. Essentially. For these. So the distance field, rather than get it from the instance lighting layers, I think we're going to get it from the brush. Like it is literally the same distance field, I'm sure it is. So what we need to do is we need to actually add a new brush tile in, which is the distance field. So we'll say if brush lighting so be for auto light layer brush lighting layers. That light layer has in it a light distance field path. we essentially need to do is go auto distance index brush index. It's brush tiles. Okay, we need different brush tiles though. So we'll make that an image. If not distance field, continue. Auto light brush tiles equals context get texture format for the distance field brush tiles, and do light brush tiles, add unique the brush. So actually, we might not need to do this. When you can go if brush lighting, we know the texture format. So the texture format is R32F, I think. What is it? R32. I think it's R32. Maybe. Like that. So if there's brush lighting, we do that. We just add the brush into the brush light context. We have to check which format it is actually though. I think it's R32. Let's have a quick look. Right. So this is the R32 one. I haven't actually written this code yet, so we'll just have to not do this. Okay, so the distance field, the format is R32. Good, right, yeah. So we do this, we just add it in. And then when we do, let's see where it actually crashed before, just then. So it's in generate textures, we call add image. So it's basically getting out the wrong image here. So this is the RGB 8 one. And this is the R32 one. What we need really is, do we want to specialize it on what type of texture? For a texture generator, like what texture format? Let's see if we can get that hooked up. So it would be like data type texture format essentially. So can we do texture format for these? And then, oh yeah, that's like this. Texture format. And then what we want to do is we want to go through all the texture formats. So turn until true. Enum couple T E texture format. And then it would be this. It's XX. So that has to happen here and here as well. It's the same apart from it's just add image. So what I want to know by doing this is if I can actually specialize. So when we do the texture generator for normal, can I actually specialize again? Like this. For eTexture format R32. Didn't know what to do. Or does everything just end up in here? So this is for Brush Tilebook RGBA 8. And that's R32. So it doesn't know. It doesn't know. We'd have to explicitly say. Or we could say that's a shame. It doesn't actually know. It doesn't do the symphony thing. It's like this is more concrete than this, so it picks this. So we could say requires texture format. Is that allowed for it requires? Okay, now let's see what happens. I mean, that's not perfect, is it? That's not great, really. Still doesn't work. Yep, okay. Well, that's that experiment. There's no way we could do it. What we'll have to do, I suppose, is let's go back. Ooh, what am I doing there? There we go. So I could just say if the brush tile is R32. The problem with that is it's just like you have to ask it for every single texture generator. What would be nice would be able to go like template Can I do this? Is this allowed? No. So this would have to be something like format. I don't know. Formatted texture generator. Or you could specify a format. Like this. And it would test that one first. Nukebird, how's it going? Hope you're alright. So in generate textures, we could do the test here. Yeah, what are you up to today? Anything good? Anything good? So I could say auto handled equals until true. This again. If constexpr is complete, and we need the generator. Generator equals format texture generator for enum value format. If it's complete, format generator we do the format generator tile set return true, let's return false. And then we can say if handled return true. Last year torturing myself to improve. Cool. Yeah, that's awesome. New challenge. Ooh. Oh, nice one. Yeah. So you're going to build this? Is it a kit? So this is pretty complicated, but you only write this once and then you never look at it again. So that goes there, and that goes also here. So let's see what happens now. Now these are written. So we should end up in here basically for the R32 one. Here for everything else. Oh, not quite. It's not as complete. It's if the tile book format FMT is equal to the FMT. Do that, and that's just return false. What image is it? Force you to use all 10. All right, okay, yes, so it's actually a typing challenge. Yeah. Yeah, awesome, awesome. I've seen those that don't even have any like letters on them. People get so good that they're just all blank. And they can just do it. That's amazing, isn't it? Alright, so we ended up here for RGB 8. And then here for the R32. That's all I wanted. Didn't end up there though for the add image. Okay, so why didn't we do that for add image? That works, the append tile set. Oh, because nothing got packed. That's why. Maybe something did get packed. No, the brush tile book didn't get packed. Yeah, okay, cool. So it didn't have to, it didn't end up in there because it didn't add an image in basically. Right, so when we end up here, we need to add in the light levels, the distance fields to the tile book basically. So auto lighting, brush tile, brush to lighting. If there's no lighting, return. So for auto layer lighting layers, do any letters to yeah, okay. Cool. Yeah, it's a lot of streams, isn't it? Yeah, thanks. That's great. I'm looking forward to actually having, you know, getting a game underway. That's going to be good. Thanks, Nukebird. Much appreciated. So the layer, the lighting layer, has the distance field. CC get image layer dot distance field path. So that's not actually a reference, that. if not distance field, continue, else we add it in. So we do this. No idea if actually append tiles, split image into tiles works with 32-bit float images. My expectation is no. Zedashaw, no, I've not heard of him. I'll make a note. Does he stream on Twitch? Zedashaw. I'll follow that person. Thanks very much. He wrote Python the hard way. Oh yeah, cool. Awesome. Right, so let's go to engine config again. Rebuild level. All right, there we go. So bit depth 32, channel count 1. I don't know if split images into tiles works with that. Literally no idea if that worked. Didn't get any. Might have to turn on and off the NAT JMC for this. Okay, I'm just gonna nip to the loo, get another cup of coffee. I'll be back in 2 minutes. Nuke Bird, still there. Never have laziness spikes. Yeah, it does happen. It does happen where I don't want to work on it. Usually, after 10 minutes of working on it, that's gone though. usually. I'll generally, if I'm really suffering, it's not the coding, it's the thing I'm coding, the thing I'm working on. So I'll change to a different part of the engine or something. Yeah, cool. Right, does this work? XY width, height. So it's got calling get pixel U32, and then it's going shift up in 24. So that's getting the alpha out. So it probably doesn't work. So that we do have the image, and we know that there is only one. There's 4 channels. Oh, hang on. We're in the wrong one. Looking at the wrong thing here. It's here we want to be in. Yeah, I was just saying that motivation. I always want a code if I'm feeling like a little bit jaded. It's usually what I'm working on. So I'll go and switch to working on something else. So tiles, what is tiles going to do? It's going to set it to 1 basically. So it's just basically picking out so this does work for it's just this shift. It isn't correct. Like we only want to see if the pixel is set. So then it will work. So what I might do is I might go it would be very easy to kind of just specialize this for any type of pixel format. Discipline and consistency. Yeah, maybe, yeah. Usually I find if I'm not feeling it, 10 minutes, half an hour of getting coding, I'm enjoying it again. It's kind of different because I just get to work on whatever I want to work on. I suppose if you did it for a job, you have to work on what you get told to work on. That'd be a little bit different, really. So this actually works. This is specifically for RGBA. I might specialize this actually to work on different formats. This is a handy algorithm. This takes an image, trims out all the white space, and builds a mesh. Not quite a mesh, an array of rectangles to represent the image. It's only really this section of the code that needs to be specialized. So we could do something like template. We don't really have such thing as an image format really. So it'd be template size T. What would it be? U32 channel count U32 bit, what's the actual bit depth? And it would be bool pixel exists like that. So we can do bool bool pixel exists for the channel count 4 bit depth 8. Yeah, I'm kind of like reluctant to do it this way just because it's just like 4 and 8, whatever that means. Which is this. We need to pass in the image as well. And U32 PX, U32 PY. And we have this thing called get tile index as well. Oh no. It's just return pixel shifted up by 24. Going on here? Stuck on running asset compiler. It's not even actually. What's going on? Internal compiler error. Internal compiler error, it says. Gonna have to reset Visual Studio. What is going on here? Internal compiler error. Is it this? I think you actually have to do a full thing. Right, there we go. Oh look, we have to do this as well. It liked that. That was fine. So I think what we'll do is by default it's true. I think it might just be more straightforward to do it on eTexture format. The thing about that is in a different library. It means something like this. Struct. I don't know. Pixel. Do we have anything called I don't want to really call it pixel. Pixel test. I don't know. And that would be enum-u32 channel count. It's channel count. And then bit depth. So channel count per depth. Like this. And this actually takes a pixel test. And then this would be pixel test 48. So we need a bunch of pixel tests. So it would be using pixel test types. R and 8. And then we just have template class T concept is pixel test type. Type is in the tuple P pixel test types, and then this is like this. So I might just call this pixel desk actually. So that's like 4 channels, 8 bits a pixel. And that's how we test whether it exists. And then we want pixel desk 1 channel, 32 bits a pixel. Look at these linker errors here. So these need to be in line really. Right. So what we want to do is so this is like a pixel exists test. So what we want is we want inline bool pixel exists. We want to go until true. Pixel, what the types. And then we want to go we want to get the type back out of X. And then we want to go if image dot get bit depth is equal to the type bit depth. Image dot get channel count is equal to the type channel count, and that return pixel exists test for the type image pxpy. All right. So now we just want to do one for channel 1, 32 bits, and that's just return pixel. So what I might do is just stick that in the image file or in the image view file. Let's get pixel. Okay, so that can go here. These are not image now though, these are image views. So now this is just if pixel exists image pxpy do that. And now, in theory, that doesn't actually matter. At least we can write little bits of code. We can write the pixel exist tests for just the different types of tests we want to support. Right then. So let's run that and just check. So here we are. This is an RGB8 one. Pixel exists. We need to, unfortunately, look at all that. Okay, so now it's going to test the 4.8 one. It's not actually going to okay. So now on the R32 one, no, missed it. Okay, now on the R32 one. Missed it again, hang on. Okay, now we're just going to test the 132, which just gets the pixel. So a distance field, the pixel always exists actually. Yeah, cool. Hey, thanks for the raid, Boogie Burrow. How's it going? Welcome, everybody. Just working on some lighting stuff at the moment. It's more exciting than it's less exciting than it sounds, though. I'm just working on the content pipeline, so getting a light from the level editor into the game data. Boogie Burrow, hope you had a good stream. Much appreciated. All this raiding, really cool. Unexcited game dev, yeah. It's exciting to me. It's not visually. When I say lighting, people think, oh yeah, lights. But it's not. There it is. Look how exciting it is. Blaze Labs, how's it going? Show you something a little bit more. So this is this is the level editor, and this is the light in the level editor. This is the game, and this is the light in the game, which doesn't exist because that's what I'm writing. Do I live in Japan? No, I don't. I live in the northeast of England. I'd love to visit Japan though. Whereabouts are you from? I'll show you a more exciting level. Any raiders? So the goal. So I'm writing a content pipeline. I'm rewriting it. It did used to exist, but it was quite kind of difficult to get new types of content into the game. So it's a rewrite really. And the goal is to get this level, which I've just made in the editor, into the game. So it looks identical, but it's been through a complete overhaul. So it's much more efficient to render and things like that. Oh, you live in Japan? Ah, cool. That's awesome. No, I live in the northeast of England. So it's not quite Japan. It is nice here though. Nice and peaceful. Yeah, so I've got pretty much so I'm working on the lights now. And then I need to get in the rivers and the ponds. And these little animated rig characters need to go in as well. A little bit off, yeah, just a little. So are you Japanese? Are you speak really good English if you are? I just live there. Are you using C++? Yeah, that's it, C++. So it's a C++ engine, pretty much written from scratch. So no real, I mean there are some libraries. Nothing major though. I'm American. Ah, right, yeah, cool. Just mid. Better than mine. I don't know any. English is mid as well. Yeah, so the goal, I suppose, I like writing the game tech, you know, the engine tech. Yeah, if anybody's got any questions, fire away, no problem. Right now, it's not looking great. There is a sprite there which looks incorrect. But that's fine because we're not finished yet. So we wrote this thing where we could split images into tiles, and then we wrote this pixel exists thing because obviously different image formats pixel exists. If a pixel exists, meaning that it's not just alphaed out to 0. It depends on the image format. So we just wrote this little routine here, this pixel exists routine. What you have to do is, if you want to actually specialize, so this is channel count, this is bit depth. So if you want 2 channels at 16 bits, you would write a little thing here. But then the actual user of the API just says pixel exists and passes in the image in the px and py. That's what I've been doing the last half an hour. But I don't think we actually want to do that because this is a distance field. Not this one. Where is it? This one is a distance field, which is a list of floating point numbers. In a distance field, every single pixel in the image is at least some distance away to the thing that is pointing to. So split images into tiles won't work because the idea behind that is it calls out white space. So if a pixel doesn't exist, it doesn't need to include it in the tile. So we're just going to use another type. What's it called? It's called like image tile. So this just takes the entire image and doesn't split it. And doesn't work by the looks of it. Oh, there's no tile size. That's why. Blaze Labs are in Japan as well. Ah, right, cool. Yeah, you can lurk. That's no problem. If you like kind of engine tech stuff, then you'll like the stream, hopefully. So yeah, the goal is to get the light by the end of the day. So within the next 2.5 hours or so, to get lights rendering in the game. Cool. Now what I want to do is check that this image tile thing actually works as well. The different formats of image. Unfortunately, if I want to regenerate the level data, I need to change this version. So I don't have like regenerate all the time. It only generates when the level data's changed, or that version changes. Anyway. So here we are. So this is the distance field stuff. So what I want to do is just basically append the distance field into the tile set. That's it. Alright, we can turn the NatJMC back on now. I have this NatJMC file which cuts out a bunch of stuff in the debugger, so I'd have to step through it essentially. Or step into it. Specifically watch Python streams. I've made a few devlogs. I haven't done one for a few months though, because it was just kind of on gameplay. So I spent 6 months or so from January to July to like prototyping gameplay for the game that I'm going to make. And then from July until now, I've been working on the editor for the engine. But when I start working on the game again, I'll probably start making devlogs again. I don't think people really want devlogs on stuff that's not as visual, you know, maybe. I don't know. People like all sorts of things, I suppose. You can share those at our devlogs on Reddit. Ah, right, cool, yeah. I'll check it out. Okay, so now we need to actually add the image in. So this is... so there's one tile range for every layer. So this is for index ref L layer lighting dot layers. Don't need to do that. And it's just add image distance fields into L layer L. More technical the better. Alright, cool, yeah. There's a bit of technical stuff in there. I don't really know where to go with it, to be honest. I want something that's quite quick to make. Obviously, like making devlogs takes a long time for every devlog. Yeah, you can check them out on my YouTube channel if you want to watch them. They're like vlogs, like video logs, rather than like articles on a website or whatever. duplicate. So we should have one tile range, 0. Now what I want to do, because this is all kind of like an untested image format really, I want to actually, so we get down to here, and I want to write this to a file, I think. Unfortunately, as well, we need a different we need to do different encoders for different image formats now. Before it was just RGB A8. Now we've got an R32 image in there, so the BC7 encoding won't work. So we'll do this. We'll do this to do now. So that's straightforward. So this is encode image to memory, really. Encode image to a push buffer. So we're gonna go eTexture format, struct image encoder, like that, and then we'll do struct image encoder for eTexture format RGB A8. Do we want it to return a push buffer? So we're going to go bool operator image push buffer result, like that. So we want one for that format, and we want one for R32 as well now. Right. So now we're going to go auto result until encoded, I suppose. Well, we don't need to test that. Until true, eTexture format. Well, enum T eTexture format. So for every texture format, so the format is equal to this. We want to say the encoder is the image encoder for the format. I say if constexpr is complete for the encoder, we're going to go if Brush tile back format is equal to FMT. We'll do encoder image DDS and true. I'll just return, yeah, return true. Return false. Like that. So then we could just say if DDS gets size, so if it has a size, then we can place it like that. So it might not be a DDS texture though. So actually it needs textures as well. And there is no push buffer. We just do this. Okay, so for the encoder now, for this, just this. This is array textures. Oops. It must return a value. So we'll just do return DDS.getSize. Okay, so now we can do a specific encoder for an R32 texture. So let's check that works. All right, cool. So now we need to do an encoder for this. I don't have a good encoder for that, unfortunately. If anybody knows a good encoder for a floating point 32-bit single channel texture, that would be good. So this really is just raw texture reader. Image.getPixels. There's no encoding at all, really. So what's a raw texture reader need? I wish IntelliSense would work. Width, height, format. So that's image get width, image get height, and the format is eTexture format R32. Like that. It's IMG though. Return true. So at least, you know, if we want to compile in different types of textures formats, we can just write these little classes to do it. It just reads it. There it is. Right. So that kind of looks broken. So what I want to do is so let's just pix. Let's have a look why that it looked kind of broken. So right now we should be at a position where not the light renders, but this, I mean, it's very hard to see. It's kind of black on black, but that looks like it's rendering incorrectly. That should actually work now. What's going on here? Because this suddenly just stopped working. D3, D12, enable experimental features. I'm not calling that. Oh, here we go. This is fixed in Pix 2509.25. 2509.25. Maybe I need to update Pix. .2509, so I do need to update it. How do I do that? Is there a way to update it from here? There's no check for updates, man. Alright. Pix. Oh, that's not what I wanted. Definitely need Pix to make a game engine. You definitely, or something like it. Render doc or something. So it better be working. Print memory representation to text. Alright, okay, yeah. No problem. I'll try and answer if I can. Alright, let's see if this works. This is a new version of Pix. Moment of truth. It does work. Amazing. Right. So it's here. If we look at wireframe, here we go. So we're getting mixed up with the meshes now. I believe that mesh is for the light. That's why. Nothing in there either. Apparently. Oh, there is. It's just alpha. How do I display just alpha? There we go. There we go. Right, so it's just because the mesh is getting mixed up. And to fix that then. So it's the mesh generator. The normal. So, okay. So the level data generator for normal. So level should have 2 submeshes in it, right? One is for the actual sprite, the other is for the light. So 562 submeshes. 566 for this first one. Tile range indices 0. So the tile book. So the texture offset. So textures, there's 2. So the texture offset there is 0. So that's the distance, that's the sprite, and that's the distance field. Pack and get bucket index. So that is 0 there. So this all looks good to me. So that's good. So this one It's been called 2 times. Oh, interesting. It's not... .562. The tile book is R32 though. Okay, so we need a different thing here. Right now it just prints to standard C out because it's easy for me. Yeah. Now I need to make a compatibility layer between this and labels in GraphViz. So I thought I needed to pass in some objects I can write output to. Okay, yeah. While you're formulating the question, I'll just nip to the loo. I'll be back a couple of minutes. Okay, so it's able to print out to console or to string or something else entirely. Yeah. So you want, is it that you want to specialize on how it's printed? So you want a callback for that? Right, so this needs the same treatment as, we need a format mesh generator. So we made a format texture generator. We need actually a format mesh generator as well. We want to sometimes specialize on different types of mesh, different texture types, different texture formats. I want to specialize on that. So do you want, are you looking for, are you going to try and use a visitor pattern to do that? Von Berg. So that's what we want. If one of them exists, we need to go there instead. So this is happening generating meshes. With formatting. Formatting the string. Have you tried to use standard format or the standard print or whatever it's called? You mean the formatting the string itself? Is that what you mean? Right, so this, we need to go, it's basically like on generate textures. We need to have one of these steps in. Format mesh generator, and then it's just this. So we want to know what format. It's just tilebook in this case. Right. So that's an RGB 8. There we go. So we end up here if we're R32, if the brush tile is R32. So we need to generate meshes a little bit differently. To be fair, it is almost the same as this, I believe. Texture index. Is almost the same. So what we're going to do is so this do this, and then we'll put this one underneath because we're going to call it. So we're just going to go. We need basically a function in here. And this one, and we can take here the submesh ID. And this just goes brush tile dot brush ID level textures tile book brush tile. That's it. And then this becomes the submesh ID. So now we can call the mesh generator normal. So we want the submesh ID, which is the light. It is the okay. Format texture generator. So we're doing it once for every light layer. Actually. So this is layer ID, level textures, tile book, brush tile. Okay, so let's see then. 3562. 64. So level submeshes. So that's that one. Texture index is 0. All right. And there we go. You can't see it, but it is rendering properly. There's no light there. Right, so that is, I think, everything in the level data now that we can use. And now we can start going on the other side on the game and trying to render it. So you don't know how cout is implemented, but I need the function to be able to print the string to the console or just write everything to a standard string. That is the output buffer. Right. Need the function to be able to print the string to the console or just write everything to standard string. Right, okay. So when you say the visitor pattern, you're going to call print. And then depending on what visitor you've sent in, it's going to print either to a string or to cout. Yeah. Yeah, okay. Yeah, so the easiest way to do that is do struct I printer or something, and then well, you'd overload the operator. You'd overload the chevron operator or whatever it's called, which I've never done before. Something like that. Something like that. It would be something like that. So then you could do like standard cout t. Something like that. I'm not really sure how we would do that. And then struct string printer. We need like a string stream, I suppose. That's what it is. String stream. Is it strings to stream? To stream? String stream. And do strut t like that. But that's iPrinter. I'm not entirely sure if that will work because it's templated. Member functions of templates cannot be virtual, so it can't be templated, unfortunately. So you would have to go. You might be able to get away with this. Maybe. But it doesn't know how that object will store the output. Yeah. Let's see if you can get away with doing this. Right, so you need an object to string method here. See, what would be nice is, so you do like, you do like string printer. Guess it'd be like that. What would be nice is to do like this. But you can't overload, so how does cout do it? Will that also work with standard endl? It should do, yeah. You'd have to do it there. Obviously, what would be nice is to be able to template this so you could pass in an actual object. Pass in 2. People hate C++. This is a lot easier to learn in C#. Yeah, yeah. So that would be go into a string. That one would go to cout. What I want to know is how cout templates that, or if it's just overridden. Whoops. Here we go. So this goes to cout. didn't print anything because I don't have a console actually. That's why I'd have to do it different. It'd have to be different in to print it out down there at the moment. But what I want to do is I want NAT. Thing is, I'm gonna have to disable NatJMC for STL, which I can do somewhere. Can I just build this with just my code? No. Let's see if we can do it now. Yeah, no problem. The goal would be to get this to work with any type, so it didn't have to. Right now, if you wanted to make, you need to do like 2 string 2 or something right now. But it'd be good just to have like 2 there. To be fair, I wonder if you could just actually do string stream. String stream. And then do t.cstra. Is that a thing? Is that real? I'm not very versed in string stream to string in STL, really. Str. Nearly right. That might be okay. Can't be well, it could. Can it be const? T.str. Yeah, it would be nice to actually be able to just put. I'm sure there'd be a way to do that. That compiles. Can't overload the same operator with different types. Yeah, it says not. Should be able to though. I don't know why. Well, you can overload it with. It's difficult. You can overload it with different types. I don't think it says. It wouldn't let me overload it with a template. With a template. Probably because it just doesn't know how to build the V table. You know, the virtual table. So you could do that. And that's nothing. That didn't actually do anything. I don't think. It's just got the new line in it, so it doesn't. That's a weird. It accepts it, but doesn't actually. Okay, let's see how this works then. I should be able to step into STL now. One that takes in a number. Yeah, you want one that would do it for it. Any. You'd want one that would do it for any type. like basically what StringStream does. Just need to be able to turn off just my code for it. Or just like search and try and find the operator overload. Yeah, it's like all of SDL looks complicated. Right, so let's put that just my code thing back on. All I need to do, I need to just find the let's have a look. I need to find the actual visualizers folder. Visualizers, here we go. So we want stl.jm default.jmc. It might be this. Or it could be the NAT step filter actually. Oh no, this is broken. It seems, but the Windows 11 seems to be really buggy. stl.natviz default.natstep filter. Not there. It's hard for me to get that image in my head of what overloads what. Well, can StringStream, this is a good test maybe. Can StringStream take an object? Like a string printer, like the printer. Probably not. So it's overloaded. It's not templated, it's overloaded. So, because this would error in a different place probably. This would error like... Yeah, look, it's like operate of long double float. So it's just overloaded for pretty much anything apart from custom types. So, if you're wanting to actually if you're wanting to actually toString any object, what you need to do, so this would have to be like, so if we do like, say I wanted to toString iPrinter, you'd have to do something like for string printer, like that, and then you would do something like template class T standard string to string, like this, and then you would do template standard string to string, have to be down here, iPrinter const iPrinter printer or something. Right. And then you could be like, I am an iPrinter. And now that goes into your string printer, like that. What's the problem here? A linker error, yeah. Obviously, it's because I'm not used to using standard string. Do you have to do this? I don't know. Oh. Maybe you just have to implement it. Yeah, you just have to implement this one. Which technically, I'm not sure. Well, whatever. He wanted to implement that one. So first... Oh, it's because it's the blooming wrong one. Silly me. So you don't have to implement it. It's the wrong one. It's because this needs to be iPrinter. Like that. I didn't write one for string printer. That's why the linker error was there. So it says, I am a printer. And it passes that sentence. I'm an iPrinter to see out. So this could be like iPrinter. This could be anything. You could do something like So that could be the iPrinter, and then you could do string printer, printer. But you can have as many different types of printers as you want. Now it's going to store it in the string stream there, with the new line on the end. There should be a way to do this as well. Let's figure that out. Without like overloading absolutely everything. Like obviously you could do this. But that means you've got to have an overload for every single one. You know what I mean? Which would be really annoying. You have to have one there as well. For every single type you wanted to. That's the way that StringStream seems to work, rather than being able to overload what you pass into there. Do you think it's a better idea to pass in StringStream always, and then just delay my C out? Let's try and riff with this a little bit more. Because what it would be nice to just do that. So can you do this? Normal string, because string always has also has appends and stuff like that. The string stream might be a little bit more careful about how it uses memory or something like that. So that works. So can I do string printer? And then can I do actually? Okay, so we've got our thing there now. There we go, that worked. That worked. So that started into the string stream. This could just be string, like. Well, the thing about string stream is it works exactly like cout works, but it stores it in a string of send instead. So you can do this type of thing where you. So string stream would probably be there. But now you've got that. So we would do something like. So you could do. So let's do struct foo in x equals 2, and then you could have void visit iprinter printer. All right, it's just printer. Yeah, I'm just talking on stream. All right, yeah, okay, yeah. Let's see if I can get this to work though. I'm kind of interested now. So that does that. So now we can make a string printer like this, and then we can do foo dot visit sprinter. So now we go make a string printer. So it's going to store it in a string. Make a foo visit with the printer, which does this, which stores its member in the printer, which makes it puts it into a string stream and calls that, which goes back. So it goes to the interface and then it goes to make the actual string stream or the string. Then it goes back to the printer that you want. So that stores it like that. So now the printer has in it 2 as a string. But if you wanted to do the cout version, it would just be an iprinter, and that should still work. Yeah, string stream's good. Or standard format is good as well. I think standard format. Probably not as good as string stream standard format actually for this. What problems does standard format solve that you can't do with string stream? Can probably allocate all of the. Well, no, it probably won't do that. So standard format would be more like. Oh yeah, that'd be great. Thank you. Yeah. You do something like this. Hello. Like that. So you could alternatively do hello. T like that. But standard format, you see, it allows you to mess with stuff in there. So if this was a float, you could do like 0.4f or whatever it is, hash 0.4f. There's codes you can put in here, and that's like float to 4 decimal places and stuff like that. If it was a float, because it's a string, it's not very interesting. So I can probably use standard format to easily format my substring. Yeah, you could do any of those things, yeah. But that works now, so you can actually just directly pass integer into there. Anything that's supported by string stream, you could pass into there. Custom types, you would have to overload that again, or write some kind of system to do that. Alright, so I think we have everything in there now. Everything in the actual game to render the light. Just have to actually do it. So let's look at game level. Tick room. I'm gonna sneeze. Excuse me. Type 2 string. Yeah, cool, yeah. That's very Java, in it, that. Or C# does it as well. The only thing with doing 2 string is it doesn't allow the it doesn't allow someone outside of your class to format the string the way they want to do it. So I tend not to do 2 string on classes. I mean, you can do, but I tend to do it from the outside, like that. Thank you. Watch me scratching myself. Just my eczema. Yeah. It's no problem. I don't think there's much, doing 2 string on a class is fine as well. I just tend to do it from the outside, really. You could do both. You could support both. Because this would be like T0, and then you could have another one. 2 string 2 D1. Because it's usually not the writer of the class. Well, not usually. A lot of the time, it's not the writer of the class that needs the string. It's the thing that wants to print out the string. And it might, want to dictate how the string looks. Two string and C#. All right, yeah, cool. C in class, cool. That's awesome. I'm gonna sneeze again. No, it's gone. Okay. So let's do the lights. So the lights have the same Z value as the sprites themselves. So we'll do it later, like we're doing it here. What I'm going to do is F0 this. Keep it as reference. For auto light in lights. C# was a lot easier getting work for the beginning. Ah, really? Yeah. Yeah. C++ is complicated. But you know, if you did know about string stream, you would have probably just gone straight to that, I think, wouldn't you? It's just like where you want one to go to a standard string and the other to go to cout. You need to have some kind of at least some interface type. Which is similar how you would do it in C#, I think, as well. Alright, so we have our light. So we have begin light and end light. Distance fields. So this now is distance fields must have been a separate thing that we stored in the level distance field. Yeah. Now we don't need to do that. Submesh texture indices, textures. So we need to pass in what textures we're going to use. Okay, so interesting. Let's just run this and see if the actual light texture is there. Yeah, no problem. Anytime, Fanbjörg, anytime. Yeah. So there's two textures. So actually, we have to make sure that the texture index for the light is correct. So that's the mesh generator. Where are we? Formatted mesh generator. So let's run that again. Make sure it's actually correct. The texture index should be 1 for the lights.
Hey Max, it's Norman. Ferment the 5 to 27.8 degrees.
Got texture offset 0.
Oh, good. Sorry. Yeah, what was it? The children.
Texture offset should be 1. Froster, how's it going?
They probably lost that batch of wheels like those bottles.
So where does texture...
All right, as long as it's in hand. All right, cheers.
Generate textures. Can't remember where texture offset gets set. Level data generator. Here. Brush tile texture offset. So where does that get set? Whoops. Here. Textures.getCount. So that needs to get set there and there. Print raw funk. All right, yeah, cool. Yeah, nice one. Print raw funk. Yeah, nice one. Ah, brill. Okay, good. Yeah, nice one. Glad you sorted it then. Alright, so this should have a texture offset of 1 now. Okay, brill. That's it. So when we want to draw the light, the light has a sprite index, so the sprite is the light. It is the sprite's light dot sprite index. Don't know about sprites. Let's pop them there then. Oh, didn't put equal sign. I'm getting tired now. Oh yeah, no problem. Still good. Nice one. Good. So we have our sprite. We want the submesh. Is the submeshes sprite dot submesh index. So that is the actual mesh for the light. Then we have begin light and end light. Draw shadows, end light. Okay, so interestingly, it doesn't use the mesh. So auto light Z is canvas get Z sprite dot position sprite dot Z bias auto token is equal to canvas begin light textures submesh. It's an array of texture indices. Well, it's texture indices 0 really. That's not really good. If token, we're just going to do canvas and light token. Alright. So light position is sprite dot position. Light dot properties. Light Z and glow Z. Light Z. Light. Glow Z. What's glow Z? Light Z plus glow Z bias. I wonder if it just draws a big square. We don't actually need the mesh. Okay, so the room IDs. Room ID is 0. No. It's if sprite dot room ID is not equal to room ID. Room name ID. Continue. So this does have where in the mesh to draw between 20 and 24, but it doesn't actually use it because I think it just immediately draws a quad, which we will change because we might want lights with multiple vertices. So go through all this stuff. So do we see anything? Oh, look, we do. It's in the wrong place and slightly drawn wrong. Basic block into a string. Yeah, nice one. Awesome. So it's slightly in the wrong place there. So I can visualize those connections. Awesome. So let's fix that. Let's see what's going on. Nearly there now. So interesting what that is. Ooh, interesting. That seems a bit squashed. So we can have a look at this texture now. Right, so interestingly there, the reason why we're getting that band is it's made it 768. The thing about textures in DirectX 12 is they have to be multiples of 256. So it's just the UV that's wrong. So that's just because we are not using the mesh. So if I did draw level submesh, yeah, this is good. This gives us a good like starting off point to just work with the level submesh instead of the light. Get that in the right place. So what I do to begin with, to draw it behind. So we're just going to go 0 for now. It's in the wrong place. So now we can... And I wonder why that is. The origin is 0, 0. I would say that the origin needs to be the sprite dot local bound center. See what that looks like. Which is nearly 0, 0. Okay. So the origin, we need to put in the actual sprite when we actually generate the mesh. So the mesh generator for normal. So it's actually when we generate the sprite. So what we're putting in as origin. Nothing. Origin. Is equal to minus width height world. Width height over 2. Let's try that. be minus 10, 10. Right. The position of the light seems wrong as well. Light P. Um, -8, -4. So I wonder what that local offset is. I think it's offset from the thing that is lighting. So what's the sprite position or the instance position? 1, 0. So -8. So if that was 0, 0, right? Excuse me. So if that was 0, 0, we would expect the light to be centered around 0, 0. That's what I would want. So we need to build the mesh to do that. What is it? Format mesh generator. Formatted mesh generator. We'll see how this works then. So what we're going to do is we're going to put in 0, 0 for the light position. Just to get us going. Right. I want to turn the Matstep JMC thing back on. So brush tile bounds is 0, 0, 0, 0. So that's why that's not working. So the brush tile bounds, the thing is there's many sprites now. So I think the world wrecked is this is just 0, 0. Not there though. Ooh, I don't know. Right, so this actually needs, rather than going to do this, we actually need a separate one. So this is just 0, 0. So the origin here, brush tile, brush origin. The origin is actually the origin's not a thing actually. It's like this. So that's also source tile. Well, source tile f.xy minus equals source tile f.width height over 2. No. It's rect world xy minus equals rect world width height over 2. That's it. Right, there we go. So it's actually, we need to draw it behind everything. Game level, just do minus max. Okay, so it's at 0, 0. So now we need to position it up to there. So I wonder if it's just that. And then in the mesh generator, there's 2 in X, it's barely any in the brush tile. So it needs to be we need to find the sprite. We need to get the sprite back out because that's got the origin in it. So we could have, just rename this, call it tree indices, but we could just call it like context indices. So we could use it actually now for sprite indices, one for each layer. So in the level data generator, bed sprites, light sprite index. So we'll just do brush. What is it? Brush tile. Context. Brush tile. Brush tile and declare identifier. What is it? It's where we go. It's the light brush tile. Do we need to add it into optref standard optional size T light brush tile X. Ooh, I don't think that's gonna work actually. Go back. Formatted mesh generator. So we have the submesh. So we can do auto sprite equals. Thing is, it's going to be multiple sprites using this. So for auto sprite, it should be in the brush origin, shouldn't it? It should be the brush origin. Try that. So the brush has an origin, which is 2 on the X, 0.75 on the Y, which is wrong. Brush tile.origin. Brush.origin. So that puts it like there somewhere. But what we want is this needs to be how far away it is. So how does this work? Normal. Generate sprite brush for normal. This is the tile origin. Yes, it's not that origin. Oh, I wonder if it's in the light file. Local offsets is in the light file. I wonder if you can get the light file then. So auto light file cc get light file layer dot light file path. And then this is light file local offset. I wonder if that's it. What is the light file local offset? -8. So I wonder if that's from the bottom. So we don't do this essentially. Let's see what that looks like. Oh, it's nearly there. It's not there though. So maybe we might redo minus the original. It's not going through it. Why is it not doing that? Here we go. All right, see what that looks like. Ooh, not quite. So what is local offset? I assume that's... Ah, okay. Got to add on the position. we go. Sprite dot position. I think that's right. Whoa, excuse me. Okay. Sprite position should be 0. Should be 1 0. Oh. The sprite position. So level data generator. This is just new sprite.position. Maybe. Let's just check. Let's just rebuild. There we go. So let's move this there. Maybe that didn't generate. Okay. Interesting, that's not anywhere near. So 20 to 24. So it should be minus 24. Just drawing it in the wrong place. Oh no, it's not. It's just focused on it. It's because the origin's there. For some reason, like the The camera just must focus on the middle of the level when it's loaded. It is in the right position. It's me getting confused there. So if I move this down there, the origin is there. Awesome. So the light being rendered in the right position now. What I need to do now is actually do another begin light call. Which is more like this, which takes in the light properties. So what does begin light look like? So basically it's doing build light quad. This is quite a complicated call, this begin light. It's doing stuff like building matrices and stuff. No, I'm alright, thank you. Okay, I think what we're going to have to do light Z, light glow Z. So it'd be the same as draw level submesh with a couple more things in there. The light properties and the glow Z. Right. Where are we? Find the right one. Okay, so it's this one. Begin light. So I'm going to do it here. So there's no shadow bias because we're a light. Lights don't shadow. And we want props Z, light Z, glow Z. Get rid of these for now. And then all I'm going to do is just copy paste this. And we'll get it to work in here. And then the game level called begin light. And the glow Z is light. So we want this. basically that. Okay, what's the problem here? We need to just make this work. So I'm going to say auto texture. Well, I'm going to say so what do we do? Do we just check that textures exists? See, textures get tag, so it's this. We're doing the texture stuff. Oh, it's not there though. It's here. We've got text bounds, so that's not what we want. World width height world, which is the submesh bounds dot width height. The light bounds is position minus origin width height world. We got build light quad vertex. Sort of getting hang of the graphics syntax. Oh, nice one, nice one. Awesome. So build light quad. This isn't a thing anymore. This is, we need basically to build the light mesh. It's not necessarily a quad. So we want light vertex, submesh, X range count. There. And there. I can also make labels on edges. Yeah, nice one. That's awesome. We want build light quad. What we want is build light mesh now. It's similar to this. So we're going to do static size T, build light mesh in world. I think it's something like that. Might not need all of those. So in build submesh index, build level submesh. I think it was just this one. Right. So this is XYUV. So data 0, data 1. I'll put offset data 0. That one. So we've got that one. That one. That one. Data 3. And that's all offset. Texture indices. So we've got an array of texture indices. Yeah, cool, Fambia, cool. I want to head off in a few minutes. So it's this texture index. Image width, height, width, image width, height, height. Wondering why we need that. Let's just place it there for now. Shadow texture index. Shadow texture index. Interesting. Okay. So we need the shadow texture index as well. That's image width, height. Right, so in the canvas now, this is build light meshing world. Submesh. Vertices. Position. Origin. Text bounds, not width, height. Shadow bias. Don't need that. Do we need all these? Don't need origin. Okay. Don't need origin. Don't need shadow bias. Texture indices. Shadow texture index. Shadow texture index. What is that? This. Camera index, yep. All right. So that this is the same apart from its glow range vertices. Text bounds. Don't know about that. I'm just going to have to put that. Do that for now. So this returns a standard optional light token. Whoops. So this is auto token, and we'll do that. This is just light Z. Let me do that. And then to do draw shadows here. Let me actually get to that. So we got submesh. Level sprite vertex. Textures. Position. Origin. Width, height, world. No shadow bias. Try and get this at least compiling before I have to go. Vertices, textures, position, origin, width, height, world, properties, light dot properties. What's going on there then? Okay. See what happens. Got 2 more minutes. So it's 20 to 24. All right, well, don't crash. There we go. It's lit. Awesome. Awesome sauce, right? That's it. That's me done. That's a good way to end. Right. Next week, I'm going to be streaming a little bit less because it's half term. I'll try and get a couple of streams in. But yeah, see you later.